All right, I'll be talking quickly about core products updates. So probably the big one was the Kokkos release. Since it was a major release, they break backwards compatibility. Kokkos didn't disappoint on that front. So in 5.0, we had to move to C++ 20. That's great. They also added some support for C++ 20 modules. But the big thing for us was that the Kokkos view was pretty much completely rewritten. It should be fully transparent, but now it uses std MD span. That comes from C++ 23, but we only require C++ 20, so they have an internal back port of the MD span that works for 17 and 20 sitting in their code base. So even though we're on 20, we are using the MD span by default. They removed tasking. I think maybe Phalanx was the only package using it in Trilinos, and that was off by default. And they removed makefile support. They also have support for multiple languages now, so you can turn on both GCC and NVCC instead of just tricking the compiler to use NVCC for everything. Yeah?
Does Trilinos actually compile with that?
With the multiple CMake languages? I have not tried it. I have not tried it.
Tried it, but I'm testing it anyway.
That's my remembrance as well. I feel like there was a ticket in from one of the Sandia groups that had tried it and wanted it on for a reason.
Mm-hmm.
Said it mostly works. I think, probably.
Okay.
So Shock was doing
That was right.
Yeah, but I don't know if they actually got Trilinos. Well,
I mean, I've got Trilinos building that way once, but I had to hack Trilinos. So
yeah, I know Rock works this way.
Yeah. Okay, so again, the compiler, minimum compiler versions, we had to tag along with Kokkos 5, so we're restricted to that. I think in your application codes, the more important thing is that there were a lot of alias, type alias deprecations. So the big one, host mirror, and scalar array is now data types, those kind of things. So that's just simple stuff to search and replace on.
I'm not positive on the GCC version for Kokkos 5. I thought they bumped it again, but I'm not 100% sure.
So I took this out of the release briefing slides from Kokkos.
Okay, perfect.
So this is not something I wrote.
Bumped up to 12. So Trilinos doesn't mess with 10 anywhere anymore.
Okay.
That's important to know maybe for.
Yeah, yeah, okay, yep. Yeah, there's actually quite a few changes. So you can go to their changelog, I have the link there, but also if you go to the Kokkos tutorials repository, the release briefings are all there. So you can get a lot more detail. There's a lot more that changed than I just trying to hit some of the highlights. They improved first touch handling for view initialization on host parallel backends. They had some type conversions for the SIMD types. For CUDA, I guess the 128-bit atomics, that they got a 60x improvement on the H100s. I think an important one, I don't know of anyone using it, OpenMP Target, but that backend is now deprecated. So the OpenMP still exists. OpenMP Target is a different backend than OpenMP. That's the one where they hand off through OpenMP to a device like CUDA. So nobody was really using it. The native backends were much faster, and there's just no institutional support for that. So that'll be going away. There were some updates for OpenACC and HIP. They fixed some performance regression. This quote came right out of the release briefing: avoid ROCm 7.1 if possible. You probably get incorrect results. I'm going to tell you the whole ROCm 7 release chain right now doesn't work for us, okay?
There's a fix. It's an LLVM developed from the hackathon we did in January. LLVM's fixed it.
The Trilinos bug,
So
okay,
and we're working on how to get it into AMD.
Did that fix the Empire ones too? No? Okay.
I was going to say, I thought things worked if you used non-GPU aware MPI. Is that not true?
There's
I thought it was like turning off the async mallocs. I thought was supposed to fix that.
That-
7.2 won't work.
That's for
Maybe we
Kokkos.
take this
Okay.
But there's a whole slew of failures, and they're all different. Yeah. Okay, so for Staccato, even though Staccato's not in this core area, I did want to mention this because the Kokkos refactor forced a complete rewrite of the Staccato internals. Okay, just hands down, the MD span, that whole design was influenced by Staccato requirements. Okay, so trying to overload a view for automatic differentiation types is tricky because you're adding an extra rank for the hidden derivative dimension in the AD. And it took a lot of code, but the way MD span was designed, it was made to make Staccato overloads easy. And so we estimate we're going to be able to yank out about 10,000 lines of Staccato code just by switching to this MD span. It's not pulled out yet because we still want to support being able to fall back to 4.7, at least for a short time, the Kokkos 4.7 release without the MD span view. But it did break a few things. We no longer support the cache FAD types, so there's some specializations of the AD types. You can no longer assign a view of FAD scalar to a view of scalars. So this was a trick to be able to access the FAD derivatives very fast. We used it in testing. But that's not going to work anymore. And you can't, some of our tests relied on this common view alloc prop. That's an internal implementation detail. You probably shouldn't know about that or be trying to use it anyway. So upcoming changes to Staccato. When you do hierarchic parallelism, there's a layout contiguous. There's a special layout that Staccato defines. We may change that to actually be a template on the FAD type itself. That would actually make some things easier. Right now, when you build a view FAD type, in your constructor, you have to pass in an extra extent for the derivative dimension. We may make that explicit. It's not just going to be adding on an extra extent because that confused people when they saw a rank 3, but then there were 4 extents being passed in. It's because it was a FAD type. And then we're working on sickle support. We do have flat parallelism working on a branch. Hierarchic's been a little bit more troublesome, and we're trying to sort that out. But hopefully, sickle support will come soon. In terms of Teuchos, the MPI routines now are wrapped in Kokkos profiling region. So if you use the Kokkos tools, you can get information there. Christian added a very nice option to the command line processor. It's going to print system info. So if you have users and you've got a weird bug and you might want to look at the hardware of the system, if they're using the command line processor out of Teuchos in their main, you can just add print system info and it's going to dump all kinds of things. Environmental flags, it'll run LDD, what modules you have loaded, MPI information, and then if you're using GPUs, it'll also get information from the SMI. Let's see, case sensitives, string validators, that's now an option in parameter lists. And a new serialization tool was added to the stack timer in Trilinos, but really it's available for all of Trilinos to use. I'll talk about that a little bit more. Thyra, the preconditioner routines can now be used directly with Tpetra objects. You don't have to wrap them in Thyra objects. So that's just a convenience. And then the gallery tool for matrix generation for our unit testing, that was converted to run on device, so a lot faster there. I want to talk about Magistrate. This is a tool developed by Sandia. It's out on GitHub. The link's at the bottom here. It's a very powerful serialization library, and it's very easy to serialize your objects. Now, you can use it to serialize to push across, say, MPI, but we use it for restarts in a lot of our applications. There's invasive and non-invasive implementations of this. This is just an example. For the stack timer, we actually added Magistrate. It can't, if you turn it on, it's off by default, so it's experimental at this point. But if you enable it, it'll download automatically during the configure process if you don't check out your own version under the package directory. And what you can do from here, this is just a simple example. You can see you can create a stack timer. You have to turn it off, but if you want to store the state before you turn it off, you can just call this stop all timers and get a list of the running timers so you know the state. Then you can just call serialize to file, and then you can restart the timers. And then when you want to deserialize it, you can just pull it back from a file. You can also do it to buffers too. This third example just shows an inline buffer instead of writing to file. So it's very trivial, but this allows us, you can imagine if we're running something that takes a week to run and the queues are 24 hours, so you're constantly restarting, well, then you got to add up all the times from all the timer logs in between, right, to get a full time. But now you can just stop and restart. Because we can restart and serialize stack timer, we don't have to do this kind of work anymore. The stack timer just has all the data. So this is just an example. If you're curious to see, there's an invasive and non-invasive way. This is the invasive way. So one of the classes inside the stack timer is the space timer. All you do is add this serialize function. It's templated on a type of serializer, and then you can just take your members and you can pipe them. And that pipe is overloaded to use serialize, or if it's a pod type, it'll just do the mem copy. It'll copy the data into your buffer that you want to serialize to. In this case, there were just 4 flags, and then a 5th flag, this running flag. Basically, we want to make sure it's turned off. So we just assert, if you're packing the data, make sure the timers are off so that you get the full accumulation of time. And then if you're unpacking, just set the running to false. So it's very clean, very straightforward to use this capability. I will say this, there is a serialization object in Teuchos that's used for the MPI communicators in Teuchos. That's a different object that is very complex and hard to write to. So this is a much simpler path to do. I don't know if we'll replace those in the end, because we're going to have to pay a lot of attention to performance before we would do something like that. But this is just an optional thing right now. Tpetra had probably the most work other than Kokkos. So there were improvements to the creation of column maps. You can see the performance improvements there. There was improvements to the sorting algorithms. We saw another speed up there, about 2x on the H100s. The copy and permute code path. We found some code paths were actually very slow on GPU. And they changed this, and we can see a 10x speed up on GPU. If you're using Panzer, that triggered this code path a lot. So this made a huge difference in our run times. But right now you have to export this use new copy and permute on. We will probably make that for the default for GPUs, but I think that there's a discussion that Tpetra has to have for that. There were cases where it did slow things down. We use MPI tags for communication now. There's unique MPI tags. There was some work on this all-to-few communication to get speed ups. I guess that was mostly for preconditioner support. Tpetra can now leverage some communication routines at MPI Advanced, so I think this is more exploratory work. But MPI Advanced is a wrapper around MPI to try and improve collectives and things of that nature. Let's see, there was a reordering of these steps for data transfer to improve performance and clean up some MPI messages, so it's kind of overlapping communication and computation a little bit better. Right now, that's also requires an exported variable to turn on. So then there were some examples that were updated to better showcase current Kokkos practices. And there was a filtering method added. So if you take a matrix and you want to filter out certain entries, there's some nice utilities now to be able to do that. SICAs. There are just so many changes there. I can't list them all out. I don't know if it's a highlight or just something very depressing, but Greg Jardima retired. So he's been the owner of that for years. And so we lost a lot of expertise there. The new owner, Tolu, is coming up to speed. So now you're going to have to talk to him about this. A couple of changes that kind of caught us on the Trilinos side. The default setting for lowercase variable names was set to false, and so that actually caught us on some customers. The Explore tool now allows names or IDs in the list and select commands. There was some research on having IOSS write the finite element database directly to or write it to an S3 database. And there's a lot more robust error checking and reporting for parallel consistency. Yep.
It's worth noting that Greg commented on one of my PRs as recently as 4 weeks ago, so he's still
He's still active. Yeah. Yeah, committing from the beach, I guess. Yeah. Zoltan, let's see, this year they added to the original Zoltan, they added these, some extra Hilbert space filling curves. So you just have a lot more options. It used to just be octree, and now they have all of these different options. Check out the ticket, it's got a lot of details about this. In Zoltan 2, graph partitioning supports complex values now for Tpetra CRS matrices, and you can symmetrize the input matrices for Zoltan 2 there as well. They also ripped out all the Tpetra support, so that's all gone. I think I've mentioned this 3 years in a row. JET multi-GPU partitioner, it's scheduled for integration. It keeps dropping on the priority list. So,
Roger, when you say Tpetra, like they actually removed the dead code?
I believe so, yes. Yep.
Roger, on the CPIS side, what's the status of Fortran? In Trilinos, since Fortran is deprecated, right?
Well, so there's still pieces, I think they use Fortran. I don't know if they're ever going to be pulled out, but I know at least for Empire, I build Trilinos with Fortran off all the time. So those tools aren't typically used by the application. Sparky's. Okay.
So I didn't quite know what we were going to do with CPIS if Fortran is pooping. Is it? I've heard rumors that it's deprecated in Trilinos.
I haven't heard
Not,
the word
not, no.
So the item I have on the build backlog is to potentially turn the default setting to off. I don't remember that anybody's ever postured that it should be deprecated. I mean, I'm not against it being deprecated, but I don't know that we've ever actually explicitly said that. I will note one of our pull request builds does explicitly build without Fortran. It's the Clang one because I didn't want to deal with mixed tool chains, frankly.
Yeah, I may be confusing like all the nonsense we have on the advanced side where they talk about like Fortran dying. It probably is dead, but.
Yeah, we don't have any active development there, but what Sam said is correct. We're just thinking about changing the default.
Yep.
I haven't checked. I'm positive we build CPIS with
But
Fortran, but we don't build
some of the
CPIS.
mains, yeah, see some of the mains for the apps that we need are still Fortran.
That's
So
right.
like, let's need to get
I think Spark built CPIS maybe independent of Trilinos or something.
They
Yeah,
talked about it in
totally.
the past, I can't remember where they said it.
So I don't know, but yeah, that was a topic that's been floating. So.
Yeah, we build, I'm pretty sure we build Trilinos with Fortran support and like those.
Right on time.
So
Yeah,
Winter built
all right.
it, and he had issues with AMD playing the new plane. And that's been a kind of a discussion because G4tran works pretty well, but classic plane is deprecated and it's not getting maintained anymore. And we're getting pushed on the new plane, which is the new LLVM compiler for Fortran. So I know that CTH works with it, but
It doesn't get CPS.
that's right. It has had issues with CPIS, even though it's at Fortran 90. It's like a pre-process. Well, it's like probably a kind front-end thing or something. I don't know. But Victor hits it in something that he's doing. I think it's Spark. I'm pretty sure it's Spark, but yeah. So.
All right, well, thanks, Roger.